Question number 30. A charge of plus 2.0 into 10 to the power minus 8 coulomb is placed on the positive plate and a charge of minus 1.0 into 10 to the power minus 8 coulomb on the negative plate of a parallel plate capacitor of capacitance 1.2 into 10 to the power minus 6 farad, 6 microfarad. Calculate the potential difference developed between the plate. Here let the Q value is given by 1.0 into 10 to the power minus 8 coulomb. Then 2Q will be 2 into 10 to the power minus 8 coulomb. Here plate is shown. Minus Q is given at one plate and plus 2Q is given at the second plate. So the phasing surface will have charge developed on the outer surface of plate A and B, that is on surface 1 and 4, on this surface and this surface, minus Q plus 2Q by 2 equals to Q by 2. Hence charge on surface 2 minus Q, minus of Q by 2, minus 3Q by 2, and charge on surface 3 2Q minus Q by 2 equals to plus 3Q by 2. So facing surface is equal and opposite surface, opposite charge. Now potential is given by V equals to Q by C, because facing surface has charge minus 3Q by 2 in magnitude 3Q by 2. So we have to put in place of Q 3Q by 2. So V will be 3Q by 2C. Using the value we get 12.5 volt answer. 31. A charge of 20 microcoulomb is placed on the positive plate of an isolated parallel plate capacitor of capacitance 10 microfarad. Calculate the potential difference developed between the plates. Here it is shown. This is a plate on which plus Q charge is placed, and this plate remains on. This is isolated plate. Now when we place the charge on this will be distributed like as shown in the figure. Q by 2 will be on outer surface and Q by 2 in this surface, because facing surfaces have equal and opposite charge. So minus Q by 2 charge will be developed on this surface and Q by 2 on this surface, so that it should be isolated. Now so we have Q equal to Q by 2, 20 microcoulomb by 2 equal to 10 microcoulomb, and given C equal to 10 microfarad. Hence V will be Q by 2, 10 microfarad, microcoulomb by 10 microfarad equal to 1 volt answer. A charge of 1 microcoulomb is given to one plate of a parallel plate capacitor of capacitance 0.1 microfarad, and a charge of 2 microcoulomb is given to the other plate. Find the potential difference developed between the plates. Again we have given two charge Q and 2Q. So first we find the charge on the outer surface, and then we will get the charge on inner surface. So we use the formula for outer surface, Q out equal to net charge divided by 2. So let Q equal to 1 microcoulomb. Charge on outer surface, on surface 1 and 4, that is this surface and this surface, Q plus 2Q by 2 or 3Q by 2. So charge on surface 2 will be Q minus 3Q by 2 equal to 2Q minus 3Q by 2 equal to minus Q by 2. Charge on surface 3 will be 2Q minus 3Q by 2 equal to 4Q minus 3Q by 2 equal to Q by 2. So facing surfaces have charge minus Q by 2 and plus Q by 2. So in the formula of capacitance we have to use this charge. Hence V equals to Q by C equals to Q by 2C, or 1 microcoulomb by 2 into 0.1 microfarad, solvent by 2 equals to 5 volt. Question number 33. Each plate shown in figure, in this figure, shown in figure has surface area 96 by epsilon naught into 10 to the power minus 12 farad meter on one side, and the separation between the consecutive plate is a 4 millimeter. The EMF of the battery connected is 10 volt. Find the magnitude of the charge supplied by the battery to each of the plate connected to it. Here this is a arrangement. This plate is connected to the positive terminal of the battery, and this plate is connected to the negative terminal of battery. There are three equal sized plate arranged in as shown in the figure. This is connected to the 4. So there will be a capacitor formed. For example, there will be a capacitor between phase 1 and 2, 2 and 3, 3 and 4. So there will be 3 capacitor. Now we have to see that what is the arrangement of capacitor. So here we see that 2 and 4 are connected with one wire. So 2 and 3 and 3 and 4 will be in parallel, 3 and 4, because one end is connected to another wire, and another end is this 3 end is connected to this positive terminal. So there will be this is a capacitor, again this is a capacitor, but these are in parallel as shown in the figure. If we see that 3 is connected here, again 3 is connected here, and 2 3, this capacitor 2 3, and 3 4, this capacitor 3 4. Again we see that this is 1 is connected, and there is a capacitor between 1 and 2. So this we see that 2 is connected to 2, again 4 is connected to 2, so 4 is connected to 2, and this is 1. So this is the capacitor. So this is the final arrangement of capacitor. Now this is in parallel, and it is again it to thus in series. So first let calculate the in parallel, only we have to add the capacitance. So equivalent capacitance equal to C into, because this will be 2C. So C into 2C by C plus 2C, 2 by 3 into C square by C, or 2 by 3C. This implies C equivalent equal to 2 by 3C, or 2 by 3 epsilon naught A by D. Difference is then given. Hence Q will be C equivalent into V, or 2 by 3 into epsilon naught A by D into V. All value is given. So using given value we get the answer 0.16 microcoulomb as a answer. Next 34. The capacitance between the adjacent plates shown in the figure is 50 nanofarad. A charge of 1 microcoulomb is placed on the middle plate. A. What will be the charge on the outer surface of the upper plate? B. Find the potential difference developed between the upper and the middle plate. Here the situation is shown. Q charge is given to it, so it will distribute a plus Q by 2 and plus Q by 2. Now facing surfaces have equal and opposite charge, so see it will be minus Q by 2, again it will be minus Q by 2, and outer surface will be plus Q by 2 and plus Q by 2. So on the first plate A, Q on the outer surface of upper plate is Q by 2. In B, find the potential difference developed between the upper and middle plates. We have to find the potential difference between these two. So we have V equals to Q by C. Now Q is Q by 2 and C is given. So Q by 2C, this value will be. So using this value 1 microcoulomb by 2 into 50 nanofarad. 10 to the power minus 6 coulomb, because micro is 10 to the power minus 6. So 2 into 50 into 10 to the power 9 farad, and solving we get 10 volt. That is potential difference between these will be 10 volt. Question number 35. Consider the situation of the previous problem. If 1 microcoulomb is placed on the upper plate instead of the middle plate, what will be the potential difference between A, the upper and the middle plate, and B, the middle and the lower plate? Now the situation is changed. We have to place the charge on this plate. So this will be distributed like this, plus Qi2 and plus Qi2, because equal and so minus Qi2 will be developed on this, and plus Qi2, because this is neutral, so plus Qi2 will be developed on this. Again minus Qi2 will be developed on this, and plus Qi2 will be developed on this. So the final charge arrangement is shown in the figure. Now Q is here Q/2, because facing surfaces have charge Q/2, so we can write V equals to Q/C or Q/2C equals to 10 volt. And this will is because in both cases facing surfaces have charge Q/2, so and capacitance is given, so in both plate both cases voltage will be 10 volt. Answer. Next 36. Two capacitor of capacitance 20 picofarad and 50 picofarad are connected in series with a 6 volt battery. Find A, the potential difference across each capacitor, and B, the energy stored in the each capacitor. Here it is shown, this is the series, so we have to calculate. In series we know that equivalent capacitance is given by formula C equivalent equal to C1 C2 by C1 plus C2 for two capacitors. Now 20 into 50 by 20 plus 50 picofarad, or 700 by 7 picofarad. So Q will be charge on the capacitor, because each capacitor will have same charge. So Q equal to C equivalent into V, or 100 by 7 into 10 to the power minus 12 into 6. 6 by 7 into 10 to the power minus 10 coulomb. Now potential across V1 will be C1 will be V1 equals to Q by C1, or C equivalent V by C1 equals to 4.28 volt, and V2 equal to Q by C2, C equivalent V by C2 equals to 1.71 volt. Answer. B, the energy stored in the each capacitor. Now we know that the formula for energy is E1 equal to 1 by 2 Q V1. So Q square by 2C equal to 1 by 2C V1 square. And similarly V2 equal to 1 by 2 Q V2, or Q square by 2 C2, or equals to 1 by 2 C2 V2 square. This is the formula. Any formula which is given we can use. Next 37. Two capacitors of capacitance 4 microfarad and 6 microfarad are connected in series with a battery of 20 volt. Find the energy supplied by the battery. 37, here it is shown. This is connected in series, so we have to first find the equivalent capacitance, which will be C equivalent equal to C1 C2 by C1 plus C2. So Q will be charge on the capacitor, will be Q equal to C equivalent into V, where V is the mm of the battery. So V1 equals to, now potential difference across one capacitor will be V1 equal to Q by C1, or C equivalent V by C1, or C1 C2 by C1 plus C2 into V by C1, or C2 V by C1 plus C2. Again V2 will be Q by C2, C equivalent V by C2, C1 C2 by C1 plus C2 into V by C2 equal to C1 V by C1 plus C2. So energy stored will be 1 equal to E1 1 by 2 Q V1, 1 by 2 C1 C2 C1 plus C2 into V into C2 V by C1 plus C2. Solving, we get 1 by 2 C1 into C2 V by C1 plus C2 the whole square. Similarly, U2 equal to 1 by 2 QV2 or 1 by 2 C1 C2 V by C1 plus C2 into C1 V by C1 plus C2. 1 by 2 C2 into C1 V by C1 plus C2 the whole square. Hence, U equal to U1 plus U2 energy stored in the system. And this will be 1 by 2 C1 into C2 V by C1 plus C2 the whole square plus 1 by 2 C2 C1 V by C1 plus C2 the whole square equals to 1 by 2 C1 C2 V square by C1 plus C2 the whole square into C2 plus C1. So finally we get equals to 1 by C1 C2 by C1 plus C2 into V square or 1 by 2 using all value given value we get 480 microjoule, and this energy is supplied by the battery. So energy supplied by battery equal to QV. Next 38. Each capacitor in figure has a capacitance of 10 microfarad. The EMF of the battery is 100 volt. Find the energy stored in each of the 4 capacitors. So here a capacitor element means, so this is in parallel and again this is in series. So first we calculate the equivalent resistance, which will be C equivalent equals to 1 by 10 plus equivalent of this 1 by 20 plus 1 by 10 or equals to 2 plus 1 plus 2 by 20 equal to 5 by 21 by 4. Hence C equivalent will be 4 microfarad. Answer. Now charge on this and this will be Q equals to C equivalent into V or 4 into 140 microcoulomb. Again this charge at this is divided into 2 parts, Q1 and Q2. Now Q equal to Q1 plus Q2 equal to 2Q as since Q1 is given, Q1 equal to as the capacitors B and C have same capacitance, so it will be hence Q1 Q2 equal to Q by 2 200 microcoulomb. Energy stored in capacitor A and D. A and D will be Q square by 2C or Q square by 2C. (400 microcoulomb into 400 microcoulomb by 2 into 10 microcoulomb). Solving we get 8 millijoule. And energy stored in the capacitance B and C. This is the B and C. C equal to Q square by 2C or Q by 2 to the whole square by 2C. This is the formula, and here charge is Q by 2. So Q by 2 to the whole square by 2C. Q square by 8C. Using given value we get answer 2 into 10 to the power minus 3 joule or 2 millijoule answer. Next question is